In this video, I'm solving problem 4.1.4. I'm going to be finding the time to maturity for a bond that's got the same price, yield rate, and face amount as another bond. So your first bond is a 6% bond maturing in 8 years that has semi-annual coupons. And again, if it didn't say semi-annual and it didn't say some other frequency, the assumption would be semi-annual. Same with the yield rate. It's convertible semi-annually. It's going to be replaced by a different bond, a 5.5% bond, yielding the same return. In how many years should the new bond mature? Both bonds not only have the same yield, but the same price and the same face amount too. All right, now I usually recommend that people make timelines in general to help them solve problems. But if you get good enough at this stuff, at least for fairly simple problems, you should be able to solve it without a timeline. Let's go ahead and solve this problem without a timeline. The price P is the same for both, and it's in both situations the present value of the future payments. Think about the 6% bond first. That's a nominal annual rate on the coupons divided by 2 to get the actual semi-annual coupon rate. 6% divided by 2 is 3%. 3% of the face value, the unknown face value, is going to be the coupon amount. That's giving us an annuity immediate. Those are payments that occur over 8 years, and there's 16 of them. We need to multiply that by A16 with interest rate that is half of 5%, 2.5%. All right, so that's the present value of the coupons. The present value of the redemption value, assuming it's the same as the face value, which would be the going assumption, would be the face value times the discount factor for 2.5% raised to the 2 times 8 raised to the 16th power. So this is bond 1. You're told that the price for bond 2 is the same. Bond 2 is a 5.5% bond. Half of 5.5 is 2.75. So the coupon amounts is going to be 0.0275 times F. And that also gives you an annuity immediate with an unknown number of payments. Now, if N is the number of years to maturity, then 2N will be the number of periods since these are semi-annual coupons. Let me put a 2N down here. Same yield rate, 5% divided by 2, 2.5%. Once again, though, over here, we have an unknown number of years and therefore an unknown number of discount periods. There'll be 2N of them. Set these two things equal to each other. You're told that they are the same, the face values are the same, the prices are the same, and the yield rates are the same. And solve for the unknown N. The value, the face value is irrelevant. They all cancel. Let's go ahead and compute what's in blue up here. Take 1.025, take its reciprocal, there's V, raise it to the 16th power, subtract from 1, divide by 0.025. This A has a value of about 13.055, multiply times 0.03, and we get 0.39165,008. I'll store that in register 1. Now compute this thing. 1.025, take its reciprocal, raised to the 16th power. We get 0.67362493. Add that to what's in register 1. And we get 1.065275001. That needs to equal what's in red. And what's in red includes an unknown N. When we calculate this A, we're going to end up dividing by 0.025. I can do that right away. I can take 0.0275 and divide by 0.025 and get 1.1. And what was the numerator of this would have been a 1 minus v to the 2n. V is known. It's v sub 0.025. It's 1 over 1.025. I'll plug that in eventually. And then we have this term right there plus v 0.025 to the 2n again. Simplify this right-hand side a bit. 1.1 times 1 is 1.1. As far as the term involving v to the 2n, you're going to have a negative 1.1 of them over here and a positive 1 of them over here. That will simplify to minus 0.1 v to the 2n. Now rearrange the equation a bit. We can write 0.1 times v to the 2n equals 1.1 minus this. 1.1 minus 1.065275010, 0.0347249. Multiply both sides by 10. And you get this. Now we're ready to take the natural log of both sides. The 2n would come out in front. In the end, you're going to get n will be 1/2 times the natural log of 0.347249 divided by the natural log of v. Let's go ahead and find the natural log of this thing and store it. I'll multiply this by 10. Its natural log is this. Store that in register 1, say. That's the top of this here. What's v? Again, it would be take 1.025, take its reciprocal, that is v. The natural log of that is this. I have to divide by that. Well, let's multiply it by 2. I have to divide by this so I can take its reciprocal and multiply by what was in register 1. And you get n to be about 21.42, which to the nearest half year is 21.5. That is correct. The time to maturity for this thing is 21.5 years, which would be the same as 43 half years, 43 periods for the situation. That is the correct answer. I double-checked with the solutions manual.